So let's look at this athlete problem. This is going to be a two-part problem. We're going to start with the weight of fat in pounds. That's what we want. So we want pounds of fat. But we start with 74 kilograms of athlete. So first we're going to take our kilograms and we're going to convert them into pounds. I don't know how many pounds, but it's converted into regular pounds of athlete. And then we're going to take our pounds and convert them into pounds of fat. So the first relationship, for the first conversion, we're looking for an equality that relates kilograms and pounds. And we find it right here. 1 kilogram is equal to 2.2 pounds. We can write two conversion statements. We can write 1 kilogram over 2.2 pounds, or we can write 2.2 pounds over 1 kilogram. For the second conversion, we're going to need to relate pounds of athlete to pounds of fat. Now let me change colors. Pounds of athlete will have 100 pounds of athlete is going to be equal to 15 pounds of fat. And I get that from this 15%. That's what that means, is that if you have 100 pounds, 15 of it is fat. So it's 15%. So we can write two conversion statements. We can write 100 pounds over 15 pounds of fat, or we can put the 15 pounds of fat on the top and put the 100 pounds on the bottom. 100 pounds of athlete. Okay, so let's look at our problem. We're going to start with this number right here. And I'm going to go back to using, let's use blue, kind of a color that's not used in any of my conversions. We'll start with those 74 kilograms. And then we're going to draw a long line. In this first conversion, our aim is to get rid of kilograms so that we'll be in pounds. So we'll want kilograms to be on the bottom and pounds to be on the top. So we're going to use this conversion statement right here. So we're going to multiply by 2.2 pounds and divide by 1 kilogram. All right, that's the first conversion. Now we have the second conversion to do. We want to change our pounds into pounds of fat. So we want pounds of fat to be on the top. That's 15 pounds of fat. And we need 100 pounds of athlete on the bottom. So we'll take 74, multiply it by 2.2, multiply by 15, and divide by 100, and we will get 24 pounds of fat. Okay, so let's look at another one. This one has a new twist because we're going to be changing stuff on the bottom. But we can do that too. This is going to be a three conversion. So we're going to start, if your treadmill on the pace is 65 meters per minute, so we've got 65 meters, it's going to be equal to 1 minute. In 1 minute, the person travels 65 meters. How many minutes will it take you to walk a distance of 75 kilometers? Okay, so we're going to start with our 75 kilometers. 7.5 kilometers. I guess we don't want to walk. That would be a little much, wouldn't it? All right. We're going to change our kilometers into meters because we've got meters right here. And so we need to know how many meters we're traveling. And then we'll use this conversion to change it into minutes. All right, so first we need an equality that will relate kilometers to meters. And let me get a nice color. How about green? Kilometers to meters, we know that there are 1,000 meters in 1 kilometer. Not kilogram, kilometer. All right, and then we know from up here that we can go 65 meters in 1 minute. So we'll start our problem, let me get back to the purple, with the number from the problem. This time I'm not going to write out the conversions. We have the equalities written, and we can write our conversions on the fly, so to speak. So our first conversion, we want kilometers to disappear. That's the one we're trying to get rid of. So we're going to put our 1 kilometer in the bottom and our 1,000 meters in the top. For our second conversion, we're trying to get rid of meters. So we'll put our 1 minute in the top and our 65 meters in the bottom. So we'll take 7.5, multiply by 1,000, and divide by 65. And we will get 120 minutes. That's how long it'll take you to walk that distance. Okay, so that finishes up that chapter. The next chapter we'll be talking about density.